Hello, all you out there in TV land. Welcome to 12.3. All right, 12.3 is all about cones and cylinders. All right, so I'm going to, again, give you an explanation of some of the harder homework problems. Number 11 says, sketch each cone and copy and complete the table. So what you're given for this cone, highlight the cone sketch. There it is. You're given that the radius of the cone is 12 and that L, the slant height, is 13. Okay, so let's just get this in a little further so we can see this. All right, this is kind of a long problem, so for those of you that just popped answers out of nowhere for me, good for you. Look how much space it took me to do this problem. Okay, so what I need to find is the height of the cone, that's this dimension right here, the lateral area, the total area, and the volume. Okay, so let's find the height first. If the radius is 12 and the lateral edge is 13, you can see, again, it's a Pythagorean triple. We love these things. The height's going to be 5. Now, just before we move on, let's figure out the area of the base. Okay, the area of the base, it's a circle, so it's going to be pi r squared. Since the radius is 12, they've given us that. It's pi times 12 squared, which is 144 pi. Now we have enough information to figure out, we have to figure out the lateral area before we can figure out the total area, so let's do that next. The formula for the lateral area of a cone is the same as the lateral area of a pyramid, 1/2 the perimeter times the slant height. But the perimeter of a cone is just the circumference of a circle, so it's 1/2 2 pi r times L. My 2's cancel and I'm left with pi r L. So this is the formula for the lateral area of a cone, pi r L, which that's nice to know. Okay, so pi r is 12, the lateral area is 13, for a grand total of 156 pi. That's units squared because it's area units. Okay, now the total area is the lateral area, 156 pi, there we go, plus the base. Now, we figured out the base up here is 144. This is the area of the base. Big B is the area of the base. So I have 156 pi plus 144 pi. That gives me 300 pi units squared. Moving on to volume now. Volume is 1/3 the area of the base times the height. Well, we figured out the area of the base. There he is right up here. So 1/3, 144 pi times the height, which we determined was 5. Okay, the height is 5. So 1/3 times 144 pi times 5, that's 240 pi. And so that is problem 11. Nice. Moving on to the next one, problem 13. This time we're given a slant height and the lateral area, and we have to find the radius, the total area, and the volume. Okay, so here's the nice picture again. Drawing cones is fairly easy. So we know that the lateral area is pi r L. We remember that from before. Okay, and they tell us it's 180 pi. And pi r L. Okay, I know L is 15, but I don't know R. So let's take a look at this. If L is 15, I don't know R, but I know the lateral area is 180. What I have to find is R. So pi times R times L equals 180 pi. So dividing both sides by 15 pi, I get R isolated here, and here I have to do 180 pi over 15 pi, which just gives me 12. So 12 is the radius. So this is a 9, 12, 15 triangle here, this guy right here, this interior triangle that you can see. And again, you'll notice it's a Pythagorean triple again, which, like I said, we love those things. This one's a 3, 4, 5, right? Multiplied by each dimension by a factor of 3. Scale factor is 3 to 1 there. Okay, so the total area is the lateral area, which they've helpfully given us 180 pi plus the area of the base. Now the area of the base is a circle, and so pi r squared is the area of a circle. So pi times r, we figured out that r was 12. Okay, so pi r squared, so that's 144 pi plus 180 pi, that gives me 324 pi for the total area, of course, units squared. Volume is the area of the base times the height, 1/3 times a third. Okay, so 1/3 times the area of the base, there it is right there, we figured it out already. The area of the base, 144 pi times a third times the height, which we figured was 9 here. Okay, all right. Okie dokie. There it is. All right, so the height is 9. So 1/3 of 9 is 3, right? I just have to multiply 3 times 144 pi to give me 432 pi units cubed. Excuse me, sorry for the crazy voice. All right, well, there's 2 more problems here. This last one, I have an area and I have a volume, and then I have to find everything else. Okay, so here we go. I know that the volume is 1/3 the area of the base times the height. They tell me that it's 600. Okay, so I'm just going to do a little substitution there. 1/3 the area of the base. I know that the formula for the area of a base of a cone, the cone is a circle. The base of the cone is a circle. So pi r squared, there's the area of the base, the area of my circle, times the height. All right. They also tell us the radius is 15. All right. And what else do I know? Nothing. Okay. So I know the radius is 15. I get that squared. I still don't know the height, but I know that that is equal to 1800. Where'd the 1800 come? When I multiply both sides by 3. My 3's cancel here, and I'm left with 3 times 600. That's going to give me 1800. And you can see that I've already divided both sides by pi as well. So that's where the 1800 comes from. So I get that 1800 is equal to 15 squared times h. Dividing both sides by 15 squared to get h, I find out h is 8. So now h is 8, right? This is this h. I know that dimension. I know the radius is 15. Oh, looky here. The slant height I can see is 17. Again, a Pythagorean triple. We love these things. Have I said that before? All right, the lateral area is pi times r times L. Having figured out L, this is just now a plug and chug kind of problem. Pi times 15 times 17. 15 for the radius, 17 for the slant height. 255 pi units squared. And the total area is the lateral area plus the area of one base. So the lateral area we just found was 255 pi, so that's where that comes from. And then the area of the base, pi r squared, pi times 15 squared, 225 pi plus 255 pi from the lateral area that we figured out. 255 pi plus 225 pi is 480 pi. So that, of course, is units squared. All right, that is problem 15. You can start to see there is a sameness to these problems. Now, this one is a fantastic problem. It's like that other problem that we did in, what was it, section 12.1, problem number 16. So this is a great question. They tell you that the ratio of the heights of two cones is 1/2, and the ratio of the radii of two cones is 1/2. So we know that the scale factor, A to B, is 1/2, right? Now what they want to know is what's the ratio of the lateral areas for two similar solids. Okay, well, we know that if we have similar solids or similar polygons, the ratio of the areas is A squared to B squared. Since our scale factor is A to B, 1/2, I just have to do 1/2 squared, which is 1 squared over 2 squared, 1/4. So any area ratio will be 1/4, whether it is a ratio of lateral areas or a ratio of total areas. And we have a ratio of volumes. We know that's the scale factor cubed because we're talking about volumes. We're talking 3 dimensions here. So A cubed over B cubed. So 1/2 quantity cubed. That's 1 cubed over 2 cubed. 1 cubed is 1, 2 cubed is 8. And so that is that answer. Okay, that is a beautiful problem. Okie dokie, that's it. Have a great weekend, folks.